Good morning, friends. Myself, Ashutosh Nikode, and today we will learn about basic things about differential equations. Means what is differential equation, what is the formation of differential equation, order and degree, and the basic methods to solve the differential equation. Generally, in this lecture, we will cover the variable separation, homogeneous and linear differential equation form. So, my first question is that what is differential equation? See, differential equation is basically it is a developing a function or developing a relation between x, y, and their derivative terms. Okay, what it means? Where x, y, I choose only x and y because we are talking about two-dimensional curve. That means y is equal to f of x type of function where x is my independent variable and y is my dependent variable. Y is depend on x. Okay, so we are talking about only x and y and their derivative terms. Means we have to develop a function in such a way that it contains x, y, dy, dx, and some constant which is equal to 0. So in this way, if we develop a function where contains x, y, and their derivative terms and some constant is there and which is equal to 0, then called as a differential equation. See, differential equation is formed on the family of curves. Means if I consider y is equal to x square, so it is, it's if I consider y square is equal to x, it is represent a unique parabola, which is look like this. But when I say y square is equal to 4ax, where a is my arbitrary constant. This a is very important here. A is my arbitrary constant. So this graph is look like this. It's represent a family of curves. It means this. If a is my negative, then this parabola is look like this and so on. So this represents a family of parabola. So we have to find a differential equation for this family of parabola in such a way that if we consider any or if we choose any point on this curve and we will find the value of x here, value of y here, and value of its derivative, then we will give means get this values, and if we put this value in this equation, in this differential equation, then it satisfies the differential equation. That is the main concept of the differential equation. So this is true for all the points throughout the curve. Means we choose any point in this curve which satisfies the differential equation. Okay, so this is the main concept, and here it is. So this is the main concept, and next we will see what is the formation of differential equation. So if I have the curve like y square is equal to 4x where a is my arbitrary constant. So if I have n number of arbitrary constants, then I have to derivate with n times. Means here I only have one arbitrary constant. Then we have to derivate with one times. Means 2y dy by dx is equal to 4a. So what is the value of a here? Which is a equal to 2y dy by dx divided by 4, which is a is equal to y dy by dx by 2. Okay, just put this value in this original equation. That means y square is equal to 4, where a is equal to y by 2 dy by dx into x, where 2 get cancelled out here, and we will get y square is equal to 2y dy by dx. This is my required differential equation. So this differential equation satisfied all these curves, all this family of curves. Okay, if we choose any point in this curve and find out x, y, and derivative, then this x, y, and dy by dx satisfied this equation. This is the formation of differential equation. Here I have one arbitrary constant, that's why I differentiate only one time. If just for example, if I have a equation like y is equal to a sin x plus b cos x, okay, and these arbitrary constants are independent. What do you mean by independent? Means if I equation like y is equal to c1 plus c2 x square plus c3x, so here are only two arbitrary constants, which is c1 and c2 completely given us c4 x square plus c3x. C4 and c3, they are two only arbitrary constants. So this is very important point to remember. Okay, so here if I have the equation like y is equal to a sin x plus b cos x, then a and b are two my arbitrary constants. Then we have to derive with respect to x for two times. That means first time derivative we will get dy by dx is equal to a cos x minus b sin x, and d2y by dx square, which is equal to minus a sin x minus b cos x. And if we common take out the common minus sign, then we will get a sin x plus b cos x, and which is equal to minus of y. A sin x plus b cos x, which is equal to y, and we will get d2y by dx square is equal to minus y. This is my required differential equation. Basically we have to eliminate these arbitrary constants. Means if we have two arbitrary constants, then we will derive the equation two times and get the values of a and b, or we will find the relation between y dy and dy by dx and d2y by dx square to get my required differential equation. Okay. So if I have, suppose if I have the three arbitrary constant in the equation, then we have to derive three times and then try to find the relation between all these x, y, and their derivative terms. Okay. So this is my formation of differential equation. Next topic is that order and degree of the differential equation. Order and degree of the differential equation. See, order is very easy. Finding the order is very easy. Means you have to find the highest ordered derivative in the differential equation. Means suppose we have equation like d2y by dx square plus dy by dx plus 2y equal to 0. Then what is the order of this differential equation? First, we have to find the highest order derivative in the differential equation. Here, dy by dx and here d2y by dx square. This is my highest order derivative term. And what's the order is? It's 2. It's the second order derivative. That's why the whole order of the differential equation is 2. So in this way, we have to find the order of the differential equation. If I have dy by dx plus c is equal to 0, notice the order, highest order derivative is this, and it's the first order derivative. That means the order of the differential equation is 1. So in this way, we have to find the order of the differential equation. See, in the exam or in the questions, they don't give us the simplified pattern. We have to simplify for some few, means we have to simplify for 2 and 3 steps, and then we will see what is the highest order derivative in the given differential equation. And in this way, we have to find order of the differential equation. Next, what is degree? Finding degree is very important. What is degree? First, to find a degree, we have to remember 2 points. First point, whatever the differential equation we have, first point is convert the differential equation into polynomial derivative form. What is polynomial derivative form? We will see later. And second term is that convert all the fraction powers into whole numbers. Means in the differential equation, suppose in the differential equation something like this d2y by dx square to the power 1 by 2 is there. So something like these terms are there. So this fraction power is not valid. Means not valid means this is not required. We have to remove this fraction order by squaring on the both side, or we have to do some operations like that. So this is the meaning of second term. What is the meaning of first point here? Convert a differential equation into polynomial derivative form. Here means basically we have to simplify the differential equation. If my differential equation is look like this, dy by dx plus e to the power dy by dx is equal to 0. Then easily you can see that derivative, highest order derivative is here dy by dx, here also dy by dx. That means highest order is this, and this is first order derivative. That means my order is 1. Okay, that's fine. But what about the degree? E to the power dy by dx. E to the power x is not a polynomial function. So if we express e to the power x in the series form, that means 1 plus x square by factorial 2 plus x cube by factorial 3 up to so on, this series goes towards the infinity. First thing is that what is polynomial? Polynomial which have two conditions. First is my powers are whole numbers, and second thing is that it is a finite sum, or it is a finite terms in the expansion in the polynomial. Here e to the power x, that is infinite terms are there. That's why e to the power x is not a polynomial function. And if we express e to the power divided by dx in terms of this, still we will get the infinite terms. That's why we will not find the degree of the differential equation. So in this case, my degree is does not exist. So this is the meaning of differential equation, the polynomial derivative form. Means some e to the power x like terms are there, then we have to express in terms of polynomial first, and then we will say that the differential equation is means the degree is defined or not defined. So these 2 points are very important. Let us do some few examples of the, if I have differential equation like this d2y by dx is good, I take very simple examples. Plus 2y dy by dx to the power square plus y is equal to 0. So we have to find out what is the order and degree of the differential equation. So clearly see that order is that what is my order is highest order derivative, which is here it's my first order derivative, here is my second order derivative. So this is my highest order derivative, that means its order is 2. And what is degree? We have to find the power of the highest order derivative. So what is my highest order derivative? d2y by dx square, and its power is 1. So my degree is 1. Sorry, I forgot to say that. What is degree? Degree is the power of highest order derivative. Okay, so in this case, d2y by dx square, its power is 1. So my value of degree is 1 and order is 2. We don't write the degree is 2 because it is dy by dx, it is the first order derivative. We have to find the power which has the highest derivative. So d2y by dx square, it is the highest derivative in this differential equation, and its power is 1. That's why degree is 1. Okay. So in this way, we have to find the order and degree of the differential equation. Next, we will see different methods to solve the differential equations. So my first method is variable separable. Variable separable. Name itself says that it's a separable, means if I have function dx and with the dx we have the function like f of x, and with dy we have the function like g of y, then we can easily integrate the differential equation and we will get the solution. Okay, so if I have some differential equation and if the variables are get separated, then we use the variable separation method to solve the differential equation. Mm, I don't write any examples here. So my second method is that this is my first method, it is variable separable method. It is very quick revision type lecture. So I can't, means I don't consider any example. Second method is my homogeneous. My homogeneous method. What do you mean by homogeneous function? Let us see what do you mean by homogeneous function. Any function f of y by x, that means the function which is in the type of f of y by x. That means y by x to the power n plus y by x to the power n minus 1 to y by x to the power 0. If the function is look like this, then we call it as a homogeneous function of order of degree n. Okay. So if my differential equation is look like this, dy by dx is equal to f of y by x upon g of y by x. Means in the denominator we have the homogeneous function and in the numerator we have the homogeneous function. Then how to solve this type of differential equation? See, in the question, the given differential equation is not directly is in that form or in the variable separable form. We have to solve, we have to simplify it, simplify first, and then we will see that what is if the variables are separated or the function is look like this f of y by x by g of y by x, and then we will proceed according to the form of differential equation. Okay, so here if my dy by dx is equal to f of y by x and g of y by x look like this, it is my homogeneous type differential equation. And how to solve this homogeneous type differential equation? Simply substitute y by x is equal to t, or you can write y is equal to xt, then dy is equal to x dt plus second and t into dx. Just write this in the differential equation and you will get the solution. Okay, so in this way, just remember this term. y by x is equal to t, and you know that how to solve the differential equation, or how to solve the integration. Okay, so in this way you can solve the homogeneous type differential equations. Okay, my third method is linear differential equation. How to solve the linear differential equation, and the type is dy by dx is equal plus py is equal to q, where q is my function of x. So if the differential equation is of the type dy by dx plus py is equal to q, then how to solve this differential equation? So we will solve this differential equation with the help of integrating factor. So what is the value of this integrating factor? It is the value is e to the power integration of p dx. Because here p is a function of x, that why p dx. So this is my value of integrating factor. And my solution is written as, let's do that proof. So this is my integrating factor. So let's multiply throughout the equation with the integrating factor. So what we will get? Dy by dx e to the power integration of p dx plus py e to the power integration of p dx is equal to q e to the power integration of p dx. Then what we will get here? Look at this term. This is the derivative of y into e to the power integration of p dx by dx. If we expand this integral, if we expand this derivative, sorry, then what we will get? This 2y is function of x, and this term is also function of x. Then we will apply the multiplication, or the multiplication form, that means u dot v. So then how we can derivate this? First into derivative of second plus second into derivative of first, that means y into derivative of this term, that means d e to the power integration of p dx by dx plus second into derivative of first, that means dy by dx. Okay, how we can express this? Here it is a derivative of e to the power x type function, that means y is here, e to the power x derivative is e to the power x itself, means e to the power integration of p dx, and with the derivative we have to multiply with the derivative of integration of p dx. So integration and derivative just cancel out, and we will get p only here, plus e to the power p dx into dy by dx as it is. So this term and this term is same. That means we can write this term as derivative of y to the power integration of p dx. So here we can write directly, we can write dy e to the power integration of p dx by dx is equal to, right hand side is same, q e to the power integration of p dx, and then we have to just integrate. So what we will get? Integration is y e to the power integration of p dx, just integration and derivative cancel out each other, is equal to integration of q e to the power integration of p dx plus constant. Okay, so we can write e to the power integration of p dx is as an integrating function, integrating factor. So simplify. So finally, we can write y into integrating factor is equal to integration of q into integrating factor plus c. This is the solution of my linear differential equation with the help of integrating factor. So in this way, we will find the solution. Next, sometimes we don't have the form dy by dx plus py is equal to q directly. Instead, we will get the form dx by dy plus px is equal to q, where is q is my function of y, here q is my function of x. So in this type, what how we write a solution? Y into integrating factor is equal to integration of q into integrating factor plus c, where my integrating factor is a to the power integration of p dx. Okay, but if we have the type look like this, dx by dy plus px is equal to q, then my solution is, first my integrating factor is e to the power integration of p dy, and my solution is y into integrating factor is equal to q into integrating factor plus c. So sorry, here x is here, x into integrating factor is equal to integration of q into integrating factor plus c. So in this way, we have to solve these two types of linear differential equation. I hope you understand what is differential equation, what is the formation of we form the differential equation, order, degree, and we will see three methods: variable, separable, homogeneous, and linear differential equation. Thank you so much.